All right, cool. I'll hold this for now. If we get to live coding, then I'll put it down and I'll use a teacher voice or something and figure it out. All right, so I just want to talk a little bit about Crystal, which is, like Rayaz said, it's a programming language that's inspired by Ruby, but it has a couple different advantages and priorities. So let's get into the the necessary quick about me. So I work at Lego with Rayaz, and I'm a huge language nerd. So as a quick aside, that includes spoken languages too. So I took French for forever throughout middle school, and then I took a year of Chinese in college, which is awesome. And I've just started learning Japanese because I think it's fun, and I can teach the language to my 18-month-old son so that he can have the cognitive benefits of being bilingual. So the love of programming languages leads you to this. So quickly, Crystal is a programming language that's like Ruby in its syntax, but it's not like superset like TypeScript is or JavaScript. It's not a superset, so 100% compatibility with Ruby is not the goal, but it is Ruby-like. It's statically typed, compiled. It has strong type inferencing, which we'll get into, and that just means that you don't have to litter your code base with super duper annoying string thing equals whatever string. You don't have to do that. It kind of can figure out most of the time the types of the things. So it gives you that benefit without being verbose and annoying. And they have the built-in concept of gems with what are called shards, and that comes with the language. And the big thing is it's a pre-1.0 language right now, so maybe don't necessarily use it in production, but you should start playing with it now because it's really cool. So that's interesting, but you can get this just from like Googling what is Crystal. So I want to talk about why is Crystal, because it sounds deep. How is Crystal? Be the Crystal. So why is Crystal even cool in the first place? So one of the big taglines that I put down here is slick as Ruby, fast as C. So it is supposed to be faster than Ruby. It runs on the LLVM, which is a really common interface for making compilers. Rust runs on LLVM. It's not really a virtual machine. It's just like a compiler from Clang. The C compiler uses that. So it's one of the things, the reasons they made it is they wanted it to be faster. But for me, the reason why Crystal's cool is actually not that that's cool, but most of our web apps, we do Ruby, so we mainly do Rails, which means most of our apps, they're not really...
Don't go too far this way.
Okay. It's not really the execution speed that slows down our apps. We're largely I/O bound, database bound. That's going to be our bigger bottlenecks. And if you're really lucky, then maybe the actual execution speed of Ruby will be your bottleneck. So for me, the bigger thing is that you get this type safety, like I said, without boatloads of annotations, which is a similar thing. Has anybody played with Elm? And Frank has. Frank's super into Elm.
I'm like baby super into it. I'm still working on the awesomeness of Elm.
That's great. Actually, I forgot to mention too, but I'm not secretly into giving overly formal talks. So I know people say this, but I actually mean it. I want this to be more conversational. So I'll try to leave room for questions at the end, but like totally interrupt me, by the way, during the talk if you have a question, so we can answer it so you don't forget later. Because I think there's a lot of good, really good, more formal talks on Crystal on YouTube, and you can watch these if you want. So I want to like talk about what y'all are interested in. So if you're interested in something, just raise your hand and we'll go over it. So I want this to be more interactive. Has anybody played with any of the languages like OCaml or Reason or Haskell or any of those? No? Okay. So has anybody played, so you've done Java, anybody else like done Java or C# or anything like that? Okay. So one of the reasons why I think this will be a cool talk is, believe it or not, there are typed languages that have type safety that aren't Java and C#. And you don't have to constantly say string thing equals string thing, new string, whatever, blah, blah, blah. And did you know it's a string? Crystal can give you benefits without changing the way to do everything, making it verbose. So let's get into that a little bit. I'll probably set the mic down in a second and I'll just try to talk really loud. But first, I want to go
like that.
What's up?
Is it ML like that?
Yeah. So ML, there's like a family of languages. So ML and OCaml, so the ML and OCaml, Haskell are in this family of languages that uses a type system. It's called the Henry Milner type system. and that's a person's name. All that really means, for the purposes of this talk, is that the type system is very, very, very smart, and it can infer your types. So it knows that we have each other name types. This is the type of thing. This is a string, or it's a number, and I'm going to make you handle it every single time. So that's a whole separate family of languages. Elm is very influenced by that family of languages. Reason ML, which is Facebook's thing, it's another syntax on top of OCaml, it's similar in that way. So I want to go over a little bit of the resources on here. I know I just said that you could go to the page yourself, but I want to point out some things on here. So I want to show you the real code. This is not a Ruby excerpt.
Do you have to use it in a bit?
Yeah. Is that big enough for everybody? So this is not a Ruby excerpt. This is Crystal code. And you notice there's not a single, I don't think there's a single type annotated here. But actually, when this is compiled, it actually knows about the types of everything in here. There's nothing it doesn't know about types in here, which is really cool. So this looks a lot like we're doing something in Ruby. And I think that they pointed out in really cool ways. So how many times in your code base, your Rails code base, do you have service object and it's taking inputs from wherever? It's doing a very simple thing, but it's getting an input from somewhere, from something. It could be a string, it could be a number, or it could be nil, for all you know. But the big one is like with forms, numbers, strings. They're kind of the same, right? Well, except when they're not. When there's a method that doesn't exist, and then you get that bug that says undefined method dash for nil class, right? Oh crap, it was a string. Or well, actually oh crap, it was nil. That's not gonna work. Well, what's really cool is if you notice there's no type annotations in here, where it says shall, right? But it does know the type of thing. In fact, you can ask its compiler and it says, oh, it's okay. I know when I went through, I saw this has a toString method in that case. And the two things I know that respond to that are an integer or a string. So it can be either one of those. And what's really cool about this is when they call, so you've got this method that takes the upcase and knows how to use a string, or anything I can call to string on, it says, oh, okay, it's actually fine if this is an integer or a string, because I can call them both. So this is completely type safe. You haven't had to specify any types, but you're not going to hit this annoying, like, oops, I expected one thing and I got another. And I think that's one of the big benefits. And the other big one is the null checks. So if you've got something that could fail and doesn't return anything, it's going to blow up and say, hey, you need to handle this. This would be nil, right? Now we can get this in Ruby. But the way we get this in Ruby is we write unit tests for it and say, oh, if I give it nil, which you probably should be doing, but what if you forget to write that test and it splits up? You might know where to fix it, but it would be really nice to know before the app even ran. Like, oh, by the way, you forgot to handle this thing. And it's okay, because I'll show you where to fix it and exactly how to fix it. So I think that's really the huge benefit here. It makes us handle things that we already have to handle in our Ruby code. It doesn't make you do a lot of extra work, but it points it out ahead of time. And the other thing is, a lot of the people who've done Java and C#, you can't do a lot of this really dynamic stuff that we love in Ruby. Like all that method missing stuff that can be dangerous, but that can also be why Rails is so awesome, is really hard to do. And you can do it if you use Java reflection, which means coming from personal experience, and even a fairly small Java app, it takes at least 40 seconds for the app to boot. It's really slow, and you still can't do quite all the same things that you'd be able to do with it. Now, method missing is not going to work with the second language, but Crystal takes maybe a pragmatic approach here and says, we still like dynamic behavior, can we do it at compile time? So it gives you macros. And these are not C macros. They're not like just find and replace macros. They're a bit smarter than that. So it gives you some information. So here we make a macro, and they say, all right, when you pass in this name, I need to know the type of everything so that I can know if I can take all these variables, I can map over them, I can make a string and see if it includes this thing. And so now you can have something like, do I have this instance variable, which is very dynamic. But the compiler has assured you can do this, and you can do it safely. So this is a nice compromise to get dynamic stuff, but also have that. The other interesting thing too is Crystal has the idea of channels built in. This is very similar to Clojure and Go code routines. So there's a concurrency primitive built in here. So it doesn't have to wait for like 3x3 or guilds or anything like that. It does have that concept built in. So look at that if you're more interested in that. And it has a nice way of doing C bindings, just like Ruby. So you can specify the types. I'm not really going to linger there because that's not super exciting. Let's head back. Are there any questions about that? Just that basic bit there. I'm going to keep speeding ahead because I want to try to show you real code if I get a chance. So there's an ecosystem that's starting to develop around Crystal. It's maybe not enough if you want to build a startup right today. Maybe don't use Crystal for that. But if you want to build a side project, there's some really cool stuff you can use. So there's Kamal. It's very Sinatra. It actually looks exactly like Sinatra. And it's actually been around for a couple of years at this point, even though this is a new language. So that one's actually fairly stable. And as far as I know, if we think of the site, they actually do have places running that in production. So that's worth. There's also Amber, which has been around for a couple of years at this point. Amber is basically, as much as it's possible, a port of Rails over to Crystal. Controllers look almost exactly the same. Pretty much everything looks exactly the same. You have an ORM that works just like Active Record. You actually have a choice. You also could instead use the other official one is based off of the Elixir Ecto ORM, which is interesting. It's a data mapper, and then they also recommend a thing called Jupyter. It's not as popular, but they say it's really good. And then the one I'm going to talk to, if we can, when we get there, is about Lucky, which is a really cool framework that borrows from Rails, Laravel, interestingly, and Elm, that's being worked on by a thought bot. Has anybody heard of Lucky? David? Yes? Yeah, a couple people. So one of the interesting things that I want to talk about is like the difference actually between these two frameworks and why they exist. Because it could be enough that we could say, well, we've got a Rails support, so we're good to go. And it's really cool that we can have that. We can have a type-safe language that also works like Rails and is convenient. But one of the things that's interesting is that while Crystal doesn't force you to change the way, for the most part, that you write your code between coming from Ruby, it does help give you better ways, push you towards better architectures, so you can get more safety, you know more upfront. And one of the things that the creator of Lucky realized is that when you have controllers like Rails controllers, where one controller is going to return a bunch of different kinds of usage, different kinds of things, you have to kind of give up on knowing some of the errors at runtime. So a good example would be you have a controller that's got a new view and an index view. And those need very different things. The variables that you want passing, or the information you want for the index, is actually entirely different from the show page, because you want to deal with a collection of things versus a single thing. Well, it'd be nice to know if you make a mistake about that up front, but because with Amber they have to return any number of those views, you kind of give up on that. And so he thought, maybe I can do better, maybe I can try a different architecture that will let virtually any problem blow up before it even runs. It won't even compile. And anybody who's used Elm will realize that that's a similar kind of thing, right? It's like, Elm is like, the compiler guides you, and it hasn't compiled, and it hasn't compiled. And you go from error to error. And then when it compiles, it kind of just works. You can still make bugs like logic errors, but you're not going to get that annoying cannot read method undefined, blank and undefined, right? So maybe we can have it with a web framework. And so that's what we get with Lucky. So I want to go in one of two directions. I want to get your input. Do you want to talk more about Lucky, or do we want to dive more into just Crystal? First. Lucky? Anybody else that wants Lucky or Crystal?
What's up, Crystal?
Crystal? All right, let's spend a few minutes going through Crystal, and then let's dive into Lucky if we've got time. So let's start with this. One of the really cool things is that they have a built-in compiler right here. So I'm going to set this mic down, and then I'm going to be my normal loud self.
WebAssembly too?
Yeah, so it can't compile to WebAssembly because they use the LLVM backend. You can use it in Scriptin and other things like that to compile to WebAssembly. So I believe this is using WebAssembly. But this is definitely the full compiler that's running here. And actually, Crystal, like other languages, Crystal is self-hosted. So Crystal is written in Crystal at this point. The first compiler was written in Ruby, and then they bootstrapped it so that now Crystal is written in Crystal. which is really cool because a cool way to learn Crystal is actually to read its own source because it's written in itself.
That's the only way to do languages.
Yeah, it kind of blows your mind at first though. It's kind of like
Sweet's written in Sweet.
Yeah, it's kind of like that picture of the hand drawing the hand, like very blows your mind kind of thing. So let's write some code and let's see some cool features of this. So I'm going to make some typical live coding exercises that are not super in depth because I'm going to mess it up anyway. So I'm not going to do the whole classic animal and dog and cat thing. That's lame. I'm going to be worse. I'm going to do adder. It's going to add 2 things, which is very exciting. And I hope you all add this to your apps. So we're going to look at a very basic class. But pretend like this is maybe a service object, because I think that that's one of the places where you'd see a lot of the benefits. So we've got this adder, and you'll notice a lot of the code looks exactly the same as in Ruby. We're going to maybe have let's do call. All right. So one of the very few places in Crystal where you have to annotate a type is right here, and it's in the initializer, which is I'm going to show you. That's actually a really nice thing. It's really only in the initializer because it has to know the types of things that are going to happen in here. So we're going to give it some really great named variables like int or like num1 and num2. I know I'm blowing your minds right now with that variable name. All right. So one of the cool things is we can set our stuff here, and it knows the types of the things. And that might not seem interesting. You're like, okay, but who cares, right? Because I do this all the time in Ruby, and I just genuinely don't care because I can test to make sure it's a number and all of that. All right. We're just going to make a... Let's see. Okay, so let's first make sure this compiles.
Wait, you got to.
Aha! No, what did you say, sorry? It's not expecting a new line here because it's actually on a per method basis. Cool. All right, so we've got our very first error here. So it's saying, hey, look, you made a method private, and you can't just call it like that, right? Okay, let's just get something small running and compile it. Cool. So it doesn't do anything yet. So let's just dump the, let's just pretty print the result. Get it printing on the side here. Okay, now this isn't very interesting, right? What is interesting is that if this was a service object, and oftentimes you're going to be getting an input in that service object from a bunch of places, and you might be totally convinced that this won't ever happen, but then some input somewhere else will give you back a float, and you didn't expect it, and that could matter. And in this case, it's like, oh, well, this service object doesn't work with floats. And that might leave you thinking, well, that's kind of a bummer, right? Because I kind of don't want this class to care. It should just take a number, and it should just do what I expect. Well, that leads me into one of the, I think, really great features of Crystal. So a common pattern in Ruby is that we want this thing to work with multiple types of things. It could be a string, it could be a number, and what we have to do is go in and check the type of the thing, which always feels a little weird to me. And so we have to have our, well, if this thing is nil, then don't do it. Or we have a bunch of that. What I would like much better is if I could say, what if I could make another initializer and just overload the method instead of putting all of those effectively different methods into one. Maybe I can just make it work with both. Cool, now it works with both floats. But then you're like, you know what? I kind of want to be able to add integers and integers. And I want to add floats, and I want to add floats. Actually, in this case, I don't care which one it is, which leads us into an even cooler feature. So we're going to make a new type of a thing, right? And we're actually going to say that we can make an alias, but we'll just do an inline thing. We're saying, you know what? This number could either be an integer or a float, and I actually don't care which one it is. And that'll still work, right? So we can even ask it what the type of the number is, and it's going to say integer 32 or float 32. What's really nice about this is if that other thing I'm calling in the service object ended up being unreliable and giving me null, Crystal already knows that before the app even runs, and it says, "Hey, look, I don't have anything that can do that. You've got a nil here, and that's not going to work. So it won't even compile." What's even cooler is that it doesn't have to just end there. But we can even say, okay, this is a string. You can make any string happen, but maybe there's only certain strings that you want. Has anybody played this in TypeScript where you can make types that are just the string templates? You can say I can only take literally these two strings, and that's it. You're about to see that. And it'll be super embarrassing if it's not in the language. I'm going to leave these horrible variable names in place. Cool.
Is that plus operator, or is that a method on those objects?
Almost definitely. This is the danger of line coding, because now I've gotten brazen and gone off my script.
You also changed your class name.
I did. Thank you. I might not get it to be happy with me. Let's say that our options are yeah, let's do this. Actually, let's not get into that. Let's look at some of the features of that real quick. An example that I know works is it's in the ducks. Unions. Here we go. Cool. So let's see. We could have, and that's the cleaner solution, by the way, in the last one where we have an infinite float. We could just say union number, and it's one of those two things. That's actually the better way.
Are the
Sorry?
values permitted types like C, or are they objects that are?
So say that again.
Are the values like numbers and strings and things, are they primitive types like they are in C, or are they objects like they are?
Oh, yeah. So actually, they're not objects like Ruby objects, but they're more involved. They're closer to like an Elm or a Haskell than C. So it's not just primitives where like you can totally say take a like where a string is basically an array of bytes or things like that. It's as a value, it's its own thing. So I don't know if that answers your question really.
So you have methods on primitives, but they're not objects.
You're right. So yes, they are built as objects. Yeah. So like
Okay.
the string. So a string is an instance of this string type. Yes, and it has a series of methods on it, and that's how it knows this stuff. So yeah, you can just call
So
methods.
it is a small function, fully up.
It is. It is. So just like in Ruby, everything is an object in Crystal. Even when you're dealing with those macros where you saw like the @type, that's actually an object that is the type information that you're getting in the macro. So yes, it is object-oriented through and through. So I'm going to skip trying to get too fancy with myself. So let's just go through just a couple of the features in here, because these are some of the best docs that I've ever seen, and I know it might be boring to have a talk that goes through docs, but I want to go through just a couple of their types. One of the biggest ones is these tuples. Has anybody worked with tuples in another language before? They're getting more popular. Yeah? Okay. Yep. So one of the nice things about them is it actually knows the type of this thing, right? And so this is pretty nice because you can say like, okay, I always get this shape, and this is always the type. So when you go to access it, you don't get this what's called type erasure, where you have to say, like some other languages you have to say like, well, it's like an array, and you just have to assume it's going to be length 3. And, well, it could be any one of these 3, so I've got to make sure what it is when it comes back out. But because they have a tuple built in, when you get the type out, it's not a union of these, it's just the string, just the character. And it knows them based on the index. It knows them as soon as you try to access them. So this is really great for anybody who's done like Elixir or something like that, where you return a symbol that's like okay or error, and then you return some sort of workable thing. The nice thing is if you forget, like, oh, what if the thing comes back and it's an error? I'm not handling that, and I have to return something. It'll let you know at compile time. So this is one of the things I think is really big, and you can name them. Procs are also strongly typed in Crystal, and you don't have to specify. You don't necessarily have to specify the types of the arguments going in. Like you do here, but anything it closes over, it already knows what's getting passed into it. So that's pretty cool, and you can pass those around as values. You can type them. You can do them. You can still call them like methods, like in Ruby. You can turn a method into a proc. Let's look at some really interesting stuff here. So let's get into these unions a little bit. These are actually going to be really common. These are actually a lot of the types you would interact with normally, because we'll get things back like a form, and maybe it's a string, maybe it's a number, and we need to be able to handle it both ways. The nice thing is, like you said, because the types aren't just primitives, they know all the methods that are in them. There are a lot of methods that work with, like we saw the toString, that work with strings and work with integers, and all it's going to do is make sure that every time you call something on A, that it works with both data types and does it at compile time. So you don't have to, if you forget an if, it's okay. The compiler will remind you it. So if you check to say like, hey, if A is a string, if the type of A is a string, then do this thing. It knows for a fact 100% that it's a string on the inside, and you know that too, that it'll be a string, there won't be null on the int. We talked a little bit about overloading. Everything else is largely the same. Class methods, variables. The only difference really with classes is that you have to say them per method, whether it's private or public. And the other difference from Ruby is that private methods are actually private Crystal. You can't just say like, oh, .send and get around it. So that's one of the very, very few syntactic differences. And here we can make our own types. We do generics. Unlike some languages, when the generic type goes in, it doesn't come out as the generic thing. It comes out as the correct type, so you don't have what's called type erasure. So here we can say, okay, I'm initializing with a value of a thing, and as long as it's the same thing, it's fine. So here you call it, you give it the type, and then you can call it with the correct type. Right? But if you say a string and .new and you give it a 1, it knows, hey, this isn't right. This isn't what you expected. And that's how they do their pointer type internally. Structs are built in, and structs are very similar to structs in Ruby, except, again, they're typed. So you can just say, this is kind of like your adder accessor and adder reader. You just say property x and y, and it knows the value of x and y. Since you specify as a property, you actually, instead of having to do that annoying like num1 equals num1 like I did before, if you specify it as a property of the class or struct, and you say x and y, because these match, and it knows that they're supposed to be a property, it'll actually just assign them for you in the initializer, which is great, because it cuts down on all that annoying like duplicated initialization. Constants are actually constants, by the way. Can't get around that either. You have your enum values based in. These aren't super exciting, but they do exist. They are kind of just like every other language. Here's maybe what's a little bit more interesting. Still have block forwarding, like in Ruby. Still have our blocks linked to procs, and we can capture input even, which is really cool. Here's what I want to get to, some of the type reflection. So this is how you ask it. This is kind of what it's doing under the hood. This is how it asks the type of a thing. So you can say A is a, and it'll tell you whether you're correct or not. So this is when you get a type that's one of these and you need to know for a fact whether it's one or the other. If you say, if A is a int32, do this, else do this, it knows for a fact in those two cases, because if it wasn't either of these, it wouldn't compile. And if you check that it's an int32, it knows for a fact that this is an int, this is a string, or whatever other series of values. And so you can safely work in there and it'll compile. And you know if that's compiling that you're not going to get that particular class of error. You can cast, which is not generally a good idea, but you can cast a value and say, I just need this, it's an int, it's fine, do the casting. But unlike JavaScript, which I work with every day, you actually have to do it, and in Ruby, you actually have to do it intentionally. It doesn't just happen under the hood. And then you've got these attributes, which these are kind of like annotations. These are just for usually metadata. These are almost always for working with C libraries, but they are there. And the boring stuff, there are like pointers and size of that you need to compiler. So there's some really, really, really low level stuff. So for me, one of the big benefits is if you noticed, we looked at a lot of initialization of things here, but actually if you look through the docs, you look through a code base, which we'll look at the lucky one in a second I have here. If you look through and see, you won't actually find a lot of type annotations in the docs. I've just shown the pages that have a lot of type annotations in them. But Crystal still knows the types. So that's what I see as the huge benefit is, instead of, if you forget to cover in your tests and blown with a nil error, it just won't even compile. This won't solve all your bugs, but it'll solve the most annoying ones, the ones that just keep you from being productive. Are there any questions about any of this stuff? Yeah?
Are there any situations, so I saw in the initializer how you had to declare the types, but
Yes.
can you declare types in other places, in other like function signatures?
You can declare them wherever you want.
Okay.
So if you want, for like more of a documentation reason, you're saying, hey, look, and actually there's a good use case to do that is when you want to be more specific. Because a lot of times if you leave it to itself, if you've used it in a couple places, it could be an int, it could be a number. It responds to both of those methods, so it could be an int or a float. And you're saying, no, this has got to be an int. I know it has to be an int. Even though where I'm using it looks like it could be both. If you specify the type, then Crystal will say, yep, that's the type, and we'll make sure that you're doing it correctly. Yeah?
So in C++ 14,
Yes.
There's actually the auto type. I've not done commercial programming, and I kind of love C a while. But then, so that works in, say, like GCC, but you step back to MC scripting, you're dropping back to C++ 11, which sort of didn't have that. Is this more like that, or is this something else?
It's more like Elm. So the auto in C++ 14 is pretty smart about telling the types of things, but it's not quite as smart as Crystal because they work differently. So the way that it works in C++ is it looks at whatever the right-hand value is and says, what's the type of that? Just give me that. Crystal doesn't exactly do that. What it does is it looks to see what have you given me and where have you used it. So when we saw in one of the earlier examples with the shout method, the reason it knew it could be an int or a string is because we called toString in upcase. And so the ints and the strings both work in that case, and that's how you used it. So it runs through the program to see your use of it, sees if there's a sense of that makes sense, and it takes that type, as opposed to just what's on the assignment. So it's a little bit smarter. Elm kind of does a similar thing. Yeah?
What does it do for memory management?
Oh yeah, it is garbage collected. Cool. It is garbage collected, and it's fairly fast, especially for a pre-1.0 language. The garbage collector is pretty fast. There are some times where Crystal can be there are some benchmarks where Crystal is almost as fast as C, which is staggering. And there are some times where the Ruby implementation, because it's written in C, is actually more efficient. But I think as time goes on, they'll be able to more and more kind of iron out those kinks because Ruby's had however long to work on it. But it is garbage collected, and it uses a generation of garbage collector with LLVM and all of that. Any other questions on this part? Yeah?
I'm getting over time. I'm just curious. Are there any differences in symbols this? Like if you have a symbol as a key, is the same as a string?
So it's not. So the string symbols are separate types, like in Ruby. But you could potentially make a hash like would have indifferent access, like you might with Ruby, and access with a string or a symbol, but they're not the same thing. Just like in Ruby, like the symbol has to be unique to that runtime. Like you can't have two of the same symbols mean different things. So they just mean itself. Does that answer your question?
Yeah.
Cool. All right. I want to show a little bit, if I can. This is really going to be daring the live coding gods. Let me put it in presentation mode. Everybody can see that, right? I want to show off Lucky, if I can, a little bit. Now this framework is really young, so it's like I said, there's one company apparently that's using it in production. There are not many, because it's very young, it doesn't have a lot of the niceties of Rails, but I think it has a lot of potential. So I kind of want to go into that a little bit. In a second we should see, here we go. It's like the work stuff I left over. Awesome. Alright, so when you first boot up a Lucky app, this is the view that you get. And it just shows you the guides in my here's the hello world. One of the things I was hoping that pop up on the screen, and it doesn't quite work when I'm sharing it, is I was hoping it would show when the browser sync finished. It was funny because you'll actually see it'll say have the Laravel symbol, the PHP framework, and say that it's done. And that's actually because one of the better features I think of Lucky is that it uses what's called Mix, which is lifted straight from Laravel. Let's see if I can get my editor back. It uses this abstraction around Webpack. So one of the things I like about Lucky is that it didn't decide to reinvent everything from scratch. It borrowed from multiple places where it makes sense. So its Webpack config is actually battle tested for several years now with other PHP framework. And why it's nice is that when you go to use it, let's pull up an example here. When you go to actually use it, you get that, kind of like with Webpacker, you get that very simple, you can mount an app and you can, when you go to mount your app, you can just in the view say, okay, asset, and grab me the asset and just let Webpack magically handle it. It does all the browser load and everything, so it's got really solid Webpack support. Back in this code. One of the things that's really cool is, so like I said, Amber is a one-for-one port of Rails, and Lucky decided to take a different approach, which is more similar if anybody's played with Hanami at all, where we have, instead of a controller class, we have a module that is all of our actions for that particular resource. So let's look at some of this code. So posts are what I've added, so this is like the start of like a little blog app. And so instead of one controller here, we have all these different actions. So we've got separate types for a browser action versus if I were to use something that was more like API focused. I have a whole separate thing that I inherit from. And what I really like about this is there's the built-in concept of a form object, which is something that when I do it in Ruby, frankly, I just mess up all the time because I forget, like, oh shoot, it depends on this thing. It depends on something, right? In this case, it's the current user, which is provided to me from the browser action. So right now the app is compiling and running, and for this form object, for it to make sense, I need to know the user because they're the one publishing the form, and if there's no user, this action doesn't make any sense. So if I forget to pass it here, which the editor might not pick up on, by the way, one of the downsides of Crystal is the tooling is young. It doesn't have the benefit that TypeScript has, where it was invented by the same people who made this editor. So it may not pick up on the error here yet, but the compiler sure did, and it said that, hey, I'm fighting the really fighting the live coding gods here. Okay. So I get these error messages, and it says, hey, look, you gave me the post form, and you didn't give me a user. I actually don't know of anything that you can use it this way. Here's all the ways that you can use me, but there's no current user missing. And so now I can know exactly where that is. It'll even show me. One of the downsides is they have a lot of macro stuff in the error messages. The good news is, at the very bottom, is where is the message where I really care. It says, like, hey, you're calling the post form new. You gave me the wrong thing. So what I like is that I could cover this with a test, but I just, honestly, I don't want the app to compile if I forget the thing, because this form doesn't make any sense without a user, and I just never want it to happen. So I won't even let you build it. And actually, the editor did complain there, which is cool. The other nice thing is, so all of these actions are typed. So show needs an ID in order to even render it. So if I don't give the post the ID, or if I give it something that's actually nil, it's going to be very angry at me at compile time and say that, hey, like, this doesn't work, or if you gave me a param that doesn't work, like nil doesn't work that way. It'll even show me here that, hey, you tried to do a route and you didn't give me the parameter that I need. It needs an ID and you didn't give me one. So it just helps you catch a lot of that kind of stuff up front. So like we saw earlier, you don't have to jump straight into designing all of your types this way. But one of the nice things is it has pushed the creator of this framework into this architecture where things are even more split up in a way that makes sense. So we've got each action is a small class, and each form itself is a separate small class. What I really like about this is that it's forced me to build very small things. And if you notice, like, the only time I did type annotation here is I just said, I need a user. Give me a user. I require this, and this is how it knows that if I even try to make this form without giving it the current user, giving it a user called current user, it's not right. But in general, you'll find there aren't type annotations here, but it does know the type of everything here. So it saves me from a lot of like really dumb stuff. It lets me get back to working on like, the actual features and stuff that I care about. Are there any questions about that part?
It reminds me a lot of priority.
Yes.
Not quite a syntax, but the structure.
Yeah, and I think there's a lot of influence here if you look through the architecture, specifically from Hanami, which is like very close to the dry RB, and the version 2 that's about to come out, they're about to be like even closer. Like Hanami is basically dry RB all the way. Where did we get that? So yeah, we've got a lot of that stuff. It actually comes with auth baked in, just some interesting convenience features. When you saw that browser action, so that's post, or this browser action is actually what gives it the concept of, actually, think of the routes here.
So are the views compiled as well?
Yes, actually that's a good point. That's a really cool thing I want to get into. So instead of using ERV or Slim or Haml or anything like that, the views are actually compiled as well. So let's look at one. Let's look at post. Here we go. So decided, it'd be also nice to know stuff about HTML. It'd be nice to know how types there too. Like, what if I put an attribute that doesn't make sense on that kind of an input or whatever? So you actually end up with this. So you have a page object, and it renders the HTML. And so def content is like the method you need to do. It's kind of like render in React, if you're used to that. And this is where you're actually going to render HTML. And the way you do it is with this built-in DSL. So H1, just like kind of like when you've done Elm, H1 is a method that gets a string or gets classes. So if we want to add like class, let's say this is, I don't know, primary and a header or whatever, we can say that. We can nest things in it by just saying do. And now we can have, this maybe doesn't make sense, but maybe if we have an unordered list, we have a list item, we can nest this way. So what's interesting is that all of the code that generates the HTML is actually statically compiled. And so there are a lot of errors, like things that are not nested correctly where they don't make sense, like a list item that's not in an unordered list, or various things like that that'll actually fail at compile time. And because the framework knows about all that stuff, it can do a lot of like really cool optimization and things like that. So this is like the actual form, and then where you render it is up here. Now, one of the things that doesn't really work with the editors yet, that has a lot of potential, is the language server. So being able to like actually jump to the definition of things and find references without having to try to use C tags. I don't know if has anybody used C tags? It's error prone, right? If you forget like to update it and whatever, like it may not work. One of the nice things is because you have that information, there's a lot of tooling that people can build, a lot of dead code elimination you can do because the compiler will know if you like never called something. So there's this concept of pages. Let's look at a bigger one. Maybe the strong types in our emails as well. But yeah, to answer your question, yeah, everything is has this field on it. It doesn't have that method. You can't have that. And so it'll let you know all of that stuff at compile time, because the way that Lucky works is it takes your schema, like your database schema, and that's the source of truth for all its types between that and the model. And it'll know compile time instead of you running into that red page of death with Rails and running into that error. Are there any questions about that? All right. So that's really, my stopwatch stopped anyway. So that's really all the stuff I had wanted to get into that I really prepared for. Is there anything else anybody wanted to know? I have as much or the time as you want. Yeah.
So you may have touched on it, but what kind of IDE support does Crystal?
Yeah, so it's pretty young at this point. So there is some basic support with TypeScript, or not TypeScript, but with VS Code. So if you look at Crystal here, there are a few. I believe there's some for Sublime Text. There's a really pretty decent one for Emacs. There's pretty decent support for Vim for the syntax highlighting. You can find the syntax highlighting with just about any editor. The editor support that's young and not available everywhere, and it's not fully featured yet, is the more of the IDE features like jump to definition, find all the references. And the reason for that is there's the language server is the one thing that's young. Scry is a shard, so like a gem that is the equivalent kind of gem that has a language server like the TypeScript language server, and it's just not a very old project. So the jump to definition, find all the references, things like that. It's pretty immature. The syntax highlighting you can find anywhere.
Are there things beyond web applications that people are building with this?
Definitely, yeah. A cool resource to check out is the awesome Crystal page, like the other ones, and they have a lot of other stuff that's in there. That's actually one of the huge benefits of Crystal instead of Ruby, is that because it's compiled, it puts out a small output, but it actually puts out a single binary, kind of like Go, so it's much easier to deploy onto devices and things like that. The bad news is there's no like Windows support yet, because the garbage collector is apparently a hard thing for them to get ported over, so there's no Windows support yet, but it does work on Mac and Linux. Puts out a small binary. So yeah, actually a really interesting use case for Crystal would be more like what you would use Go for, like small processes, more like daemon or a CLI app or something like that. Yeah, so there are people who are doing stuff like that. Actually, most of the talks I've seen where people are talking about actually using it, that's what they've used it for, is they've used it for like a CLI app or like something that watches other files and compiles them kind of like Guard, but like much faster. So that's where they're using it a lot, is like small little processes that you run, like they could just as easily be a shell script or could easily be a Go binary or whatever.
And since it's not 1.0 yet, are there known limitations that people are going to run into when they try it?
Yeah, so one of the biggest ones is the biggest limitation is for people who want it is the Windows support. It's not just that it doesn't work well, it's just it doesn't work at all. The other one is that because it's pre 1.0, they do still sometimes make fairly big breaking changes.
Sure.
When we showed earlier the constructors, we had to declare the type. It didn't used to be that way. it would try its best to infer the types, but the type system had to try really hard, and it just didn't give you as good of information. And so in one of the more recent versions, they decided that actually wasn't a really good developer experience, and so they're just going to say, we're going to force you to annotate that. The good news is when something like that changes, because the type system can help you a lot, it'll kind of just point to like, fix this, fix this, fix this, fix this. But it's really, that's the big limitation, is just that one, the ecosystem for there are not nearly as many shards as gems. There's not like, Will Paginet or Kaminari or anything like that that's as battle tested. Some of them exist, but they're not as battle tested. And then the fact that the language still kind of reserves the right to make breaking changes. So that's the biggest limitation. As far as the language itself, there's no like specific glaring, huge limitations. And part of that's because it's built on the LLVM, which is a very, very mature compiler framework. There's a lot of stuff that you kind of get for free with working with architectures. Yeah?
Is this for the overloading for methods as well as constructors?
Yes, so the constructor is just another method, so you can actually overload any of the methods.
Yeah.
So which is actually probably the bigger use. Like overloading constructors is kind of whatever, but overloading methods is probably the bigger one, because that's where we tend to use it more. Instead of having all of the guard clauses, you can get rid of a couple of the guard clauses by just having separate versions. And it does know how to choose the correct one, and you don't lose any type information when it chooses that, yeah.
So in practice, do you actually, does the typing system ever kind of get in the way, like the inferred typing? In practice, do you actually have to specify the type?
Yeah, it can at times. One of the best examples was that shout method we saw earlier, where it does try to determine, like, okay, we called to string, so what types do I have to respond to that? And then it'll give you that type. Where it's going to get usually in your way is if you haven't fully thought through something yet, and say, like, I'm using it as an integer or string, but I'm only right now. I'm just going happy path. It is going to, when you try to call a number method on that, it is going to say, hey, well, this may not be a number. You need to handle it. But the good news is it usually only happens when that would actually be a bug. So it's definitely possible that at times it's going to occasionally require a type signature, but it's not like a Java where you have to come up with all of those classes and types up front. You almost never have to specify the types. And when you do, it's to prevent ambiguity. So the only time it forces you to is when it has no idea how to choose what it was. So it doesn't force you to adopt a totally different paradigm. It is still slightly different than Ruby. You can't just copy and paste Ruby code over. But a lot of the way that we're used to working with things in practice will be the same. But it'll help encourage you into a different direction that's actually going to potentially be cleaner. Yeah.
Does it support multiple inheritance?
That's a good question. No, it doesn't. It takes the Ruby approach. So, okay, so it doesn't support multiple inheritance, but it does support modules, which is kind of multiple inheritance. So it supports modules and classes similar to Ruby. So that part is very, very, very similar. The good news is if you override a method from a parent incorrectly, you get to know that up front. Or if you call super incorrectly because super is typed, it knows that, like, oh no, you didn't give it the right thing. So it works very similar, except for that can give you a little more information. Anything else?
You may have touched on it, but does it have to do with dependency management, like with require? Is it similar? Or?
That's a good question. Yeah, actually, so it does need to know because it's compiled. When you go to require, if there's no method in there, it's going to complain. As far as the in-depth of the module system and how it resolves stuff is to be honest, beyond me. As far as how it actually resolves the modules, but because it's compiled, it actually does care deeply about requiring things correctly. Yeah. Yeah, we'll go here.
Is their main site the best place to find or anything? It'd be fun to play around with it, but is that like their main source of info? Or
Yeah, I find that there are some tutorials and stuff out there you can check out if you want. I've personally found that their docs are some of the best docs I've ever seen because they tend to give simple examples and then try to give more in-depth examples. And they've got pretty much anything you could want to do in there covered. But I think that this is just a cool way to get started is with that little sandbox. And so I think a really cool exercise is honestly just write something in Ruby that you're used to. Something fairly small you can copy and paste in here. Copy and paste it and see what it tells you. You know, the syntax isn't exactly the same, but follow the compiler errors and then just mess with it. And the fact that you can use your browser here, you don't have to install it, you don't have to do whatever. Like, it's pretty convenient. When you do want to install it, it's as simple as doing it with Homebrew or with a similar package manager. They have the Crystal stuff. It comes with the shards executables for when you install packages. And then, frankly, that's
Yes, I mean, maybe you could look back at any period of time and say, well, in the 80s we had iPhone and we had all these other things. But it seems like we're living in like the golden age of experimental languages. Like, there's more than I've ever heard of before, which is awesome. I mean, we've got three paradigms, right? Functional, object-oriented, and procedural, or whatever. What do you think if Gnostic takes something like Crystal and moves it towards the mainstream, or Elm and moves it towards the mainstream, or is this, you know, really fascinating your science stuff and stuff we can use for our own stuff, but maybe you want to embark for like a project that?
Yeah, I think there are two main things we can do to push a language like this more mainstream, if that's as a community what we want. One is it's about the ecosystem, right? The reason I love Ruby, and that's one of the reasons why I like using Rails, but to be honest, one of the big reasons I use Rails is the ecosystem is extremely strong. Like, I could try to use Hanami in production, or Padrino, or even Sinatra, but one of the reasons why I like Rails is because the ecosystem is strong. The reason so many people build so many apps with Laravel is not because PHP is necessarily the best language in the world. It's not the worst either, but it's not because of PHP, but because the ecosystem is extremely strong. So I think one thing we can do is, if you genuinely find this fun, build something useful. Because that's one of the reasons why we get to do Ruby every day anyways, is because DHH loved Ruby so much, he decided to build something useful with it. And we all use it now, or almost all of us use it now. So I think that's one thing, is we just think it's fun, build something useful that's missing. The other thing that I think is just as big that a lot of talks miss out on is that the other thing you can do to bring it in the mainstream is actually to just try to apply some of these principles that you think are good and bring them into Ruby with you. Right? So that doesn't mean that we have to write static types in Ruby. It doesn't necessarily mean you have to be like Stripe and have a type system on top. But if you find it useful, maybe that is something you do. Or maybe we can write tooling that statically analyzes Ruby a little bit stronger, gives us some of the benefits. And I think that a good use case of that is when we look at and see we need concurrency in Ruby. What should we look at? And so maybe we go. Right. Well, we go with the guild, but we might have started and looked and said what does Go do? Now we won't necessarily do what Go does, but what do they do? Is it useful? And that's what Crystal did. They said, actually, this paradigm works well for our language. Let's just use that. I think that bringing things back with us that we're used to the languages that we use every day is just a huge boon for that language too. That's personally what's worked for me with Elm. I don't use Elm in production. I've only played with it, but I can tell you for sure that Elm has changed the way that I write JavaScript, and even the way I use TypeScript. But it's changed the way that I write, and I often spread that when somebody asks why are you doing it this way? One of the reasons I point them to Elm, just go play with Elm. You'll kind of get it. This is why I like to write it this way, because it saves me these headaches. So cool. Well, if there's nothing else, then I think that's it.